Hello, thank you for watching this video. So in this video we're doing question 10 of May, June 2023, question paper mathematics paper 2. And the topic is still Euclidean geometry, as you can see here, together with some, I don't know, we'll see. So they are saying in the diagram, TR is the diameter of the circle. PRKT is a cyclic quadrilateral. They went on to say that chords TP and KR are produced to intersect at S. Chord PK is drawn such that PK is equal to TK. Right? No problem. They're saying this diagram, TR is the diameter, right? TR is the diameter of the circle, right? Which means, you know, a diameter is a chord that passes through the center. So it's a special kind of a chord that passes through the center. So they went on to say that PRKT is a cyclic quadrilateral. PRKT, this shape here, is a cyclic quadrilateral. What is a quadrilateral? A quadrilateral is just a four-sided shape, for example, a square, or your trapezium, or your rectangle, or your rhombus, or your all the parallelograms, right? It's just a four-sided shape. In this case, just a four-sided shape. It doesn't even have a special name, this PRKT here. So when you say your quadrilateral is cyclic, which means all the vertices, which is all the corners of your quadrilateral, they lie on the circumference of a circle. So which means your P is on the circumference, your R is on the circumference, your T is on the circumference, and your K is on the circumference. That's what it means to be cyclic, which is all the vertices, all the corners of your quadrilateral, they lie on the corner of your circle. All the vertices, which is the corners, they lie on the circumference of your circle. That's what it means to be cyclic quadrilateral. And you know by now, which means you can watch from my bed actions sessions. Go to the playlist and check out the bed action sessions. You will see that I've taught the cyclic quadrilaterals. What I've said on the cyclic quadrilaterals is that the opposite angles of a cyclic quadrilateral are supplementary, which means if you add P1 and P2 and K1 and K2, they will add up to 180 degrees. If you add T1 and T2 and R3 and R2, this angle and that angle there, they add up to 180 degrees. I said that the opposite angles of a cyclic quadrilateral are supplementary, which is they add up to 180 degrees. Property number 2 about a cyclic quadrilateral, you say that an interior angle of a cyclic quadrilateral, exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So if you're looking at PRKT, it's a cyclic quadrilateral, right? So look at TP. If you extend TP to S, right? Now, PS is an extension of TP, right? Look now, that angle P3 is an outside angle. It's called the exterior angle of a cyclic quadrilateral. So it's an angle between the extension and the closest side, right? So this angle P3. So this angle P3 is equal to angle K1 and K2. So if you add K1 and K2, they should be equal to P3. So that P3 is an exterior angle of a cyclic quadrilateral. And this K1 is the opposite interior angle, or interior opposite angle. In a similar way, look at KR. KR is one side of the cyclic quadrilateral. KR is extended to S. So which is, now this angle R1 is an exterior angle, right? Which means the exterior angle is the angle between the extension and one side, and it's less than 180 degrees. So your R1 is equal to T1 and T2. No problem. They went on to say that chords TP and KR are produced to meet at X, S, which is TP and KR, they're extended to meet there at S. Fine. They went on to say that PK is drawn such that PK is equal to TK. So we're saying that PK is equal to TK. So which means this length is equal to this length over here. So if you look at triangle PKT, you are looking at an isosceles triangle. So PKT is an isosceles triangle. So you know that if you have an isosceles triangle, the angles that are facing equal sides are going to be equal. Look at this side and look at this side. So this angle T1 and T2 is facing this side. This angle P1 is facing that side, which is this angle and that angle are equal. So the base angles of an isosceles are equal. So before we even start with the question. We can just analyze this and say, okay, let's say this is our triangle PKT, right? Let's say this angle here is equal to x, right? This one here is also equal to x because these are angles facing, no, not this one, sorry. This one over here is also equal to x. Because look, this side is equal to this side. So the angles that are facing, which is their opposite equal sides, are also going to be equal on your isosceles triangle. Right? No problem. So this entire angle, let me write this x here, so that we see that this x is the entire angle. So this angle and that angle are equal. But look at this angle and that angle. P1 and R3, they are both subtended by the same chord, TK. So this angle and this angle, they are both subtended by this. They are both formed by TK, both of them. So this angle here as well should also be equal to x. These are angles in the same segment. So all information that I've entered in red is the information that we entered ourselves. We were not given, right? No problem. Also, if you look at this, we said R1 was an exterior angle. Exterior angle of the triangle is equal to the interior opposite angle. So this angle here is equal to x as well, if we were to look at it that way. Right? No problem. Yeah, I think that's all I can say for now, at least. But we can say this is equal to this over here. These are angles in the same segment. And we can say this angle here, this small angle here, is equal to that angle over there. These are angles in the same segment, right? What else? Well, maybe if you want, you can think of this and say it's the same as that one. These are angles in the same segment. They're subtended by the same chord. Fine. Let's go. They're saying, prove giving reasons that SR is a diameter of a circle passing through S, P, and R. So they want us to prove that SR is a diameter of a circle passing through S, P, and R. So there's a circle passing through S, P, and R. So let's say this circle looked like this. I'm going to write it in red. S, P, and R. So there's a circle that passes through these points. Right? So they're saying, they must show that SR is a diameter to that circle. So what do we know about diameters? So if you want to prove that this is a diameter, what do you know about diameters? So you know that diameter is a special kind of a chord that passes through the center, right? And also, you know that your diameters, they subtend 90 degrees. Your diameter subtends 90 degrees. For example, in this case, we're told that TR is a diameter, which means look at your TR over here. TR subtends K, which means this should be 90 degrees, this angle here, this entire angle here. Because it's an angle that is subtended by diameter, because it's formed by diameter TR. And look at P1 and P2 is also subtended by the same TR. So which means this angle over here is also 90 degrees as well. Fine. So we want to show that this SR is a diameter. To show that SR is a diameter, you must show that it subtends 90 degrees, which means you must show that this angle over here is 90 degrees. Right? That's what we need to do. How do we say that? We said P3 is an exterior angle and it's equal to that angle, and that angle is 90 degrees. We're done. So in this case, but we have to reason from the beginning, reason from the bottom, and say, okay, K1, angle K1 plus angle K2 is equal to 90 degrees. So this angle here, angle K1 plus K2, is equal to 90 degrees. Why do we say that? We say this because it's an angle subtended by diameter KTR. So we say angle in semi-circle, which is angle subtended in half a circle. Angle subtended in half a circle is subtended by a diameter, so it should be 90 degrees. We know that. We're trying to prove that this is 90 degrees. But look now, K1 and K2, this angle here, is equal to that one because P3 is an exterior angle of your cyclic quadrilateral. P3 is an exterior angle of your cyclic quadrilateral. I said an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The same way I said this is equal to that. So in that case, we can say now we can say this K1 plus K2, which is equal to 90 degrees, is also equal to what? Is equal to P3. Right? The reason we say this angle K1 and K2 is equal to P3 because P3 is an exterior angle of a cyclic quadrilateral. P3 is an exterior angle of a cyclic quadrilateral. An exterior angle of a cyclic quadrilateral is called the interior opposite angle. So we know that this is 90 degrees. It should be red because it's what we're entering ourselves. No one told us this thing. 90 degrees. We can say now, therefore, SR is a diameter to that circle. Why? Because our chord SR subtends 90 degrees. That's it. We're done with 10.1.1.1. Now, we move on to 10.1.2. What are they saying at 10.1.2? At 10.1.2, they are saying, prove, given reasons, that angle S is equal to P2. So they want us to prove that angle S is equal to P2. Where is angle S? Angle S is this angle over here. This angle over here. So they are saying it's equal to this one over here, which is this is equal to that. That is what they want us to do. No problem. So how can you go about this? Look, SPR is a triangle, right? But look now, if you look at P1 and P2, P1 and P2 is this angle, which is this 90 degrees over here. It is an exterior angle, it is an outside angle of this triangle. You know that an exterior angle of a triangle, because look, you have SPR, right? And this PT is an extension of SP. If you extend SP, it will go straight to T. So the angle between the extension and the one side of a triangle, that is an exterior angle, the same way I define the exterior angle of a cyclic quadrilateral. So in that case, what do? We say if we add S and R1, they should give us this exterior angle over there. So we're saying angle S plus R1, they are going to give us what? They are going to give us the exterior angle, which is P1 and P2. What is the reason? This is an exterior angle of a triangle, which is an exterior angle of a triangle, which is this angle, is equal to the sum of the interior opposite angle. So this angle P1 and P2 is equal to the sum of the interior opposite angle, which is the angles, or you can say the exterior angle of a triangle is equal to the sum of the interior non-adjacent angles, which is, in order to find the exterior angle, add your interior angles, but only the non-adjacent ones to the angle that you are sitting on. So, in that case, no problem. Look now, you have at least managed to connect S and P2. You can see S and P2, which is, these are what you're trying to find. If you can show that R1 and P1 are equal, what that will do, if you can show that R1 and P1 are equal, then these two will cancel out, and you'll be left with S1 equal to P2. But look now, look, there's X here, this one is X and that one is X. Which means we already made this connection already that they are equal. But we need to show it, which means we said P1, right, is equal to, P1 is equal to T1 and T2, because these are angles opposite equal sides of an isosceles. And we said this is equal to that because that is an exterior angle of your cyclic quadrilateral. So in this case, we're going to say, okay, our P1 is equal to T1 plus T2. We're going to say, okay, let me start by saying, in triangle, PKT, maybe PKT, I'm going to say our PK is equal to, our PK is equal to TK. Why? Because we were told this thing, this was given. You can see, no problem, it's in black. Then we're going to say, therefore, angle P1 is equal to angle T1 plus T2. Why? These are angles opposite equal sides of a triangle. Right? No problem. But T1 and T2 is equal to R1 because R1 is an exterior angle of a cyclic quadrilateral. You know, an exterior angle of, because here is a cyclic quadrilateral. And you can see that KR is extended to there, which is the angle between the extension and one side of your cyclic quadrilateral is an exterior angle. And it's going to be called the interior opposite angle. You can say, therefore, T1 plus T2 is equal to R1. Why? Because exterior angle of your cyclic quadrilateral. Right? No problem. So look now. Your T1 and T2, your T1 plus T2 is equal to P1. The same T1 and T2 is equal to R. Which means these two things are equal. Because look, I can say P1 is equal to T1 plus T2, which is also the same as R1. So we have shown that P1 is equal to R1. Right? So we should, on this top thing, we can have P1 here and P1 there because P1 and R1 are the same. So let's substitute P1 in the place of R1. So your angle S plus P1 is equal to P1 plus P2. So this and that will cancel. Therefore, your angle S is equal to angle P2. We're done with this. We've shown 10.1.2. Okay, so now we're doing 10.1.3. They are saying prove giving reasons that triangle SPK is similar to triangle PRK. So they want us to show giving reasons that triangle SPK is similar to triangle PRK. Triangle SPK is similar to triangle PRK. So what does this mean? So if you're trying to show that two triangles are similar, you are saying they are scaled versions of each other. It's more like you're looking at the same triangle, but they might be of different sides or maybe exactly the same size. So they look the same, but they look exactly the same, they're identical, or they look similar, but they have different sizes. How do you prove that two triangles are similar? You should first show that the corresponding angles are equal, right? Which means, in this case, you must show that maybe your angle S in the first triangle is equal to angle S on the second triangle. No, it's equal to your angle S in the first triangle equal to angle P on the second triangle. Your angle P on this triangle, right? So it's SPK, and PRK, which means your angle S on this triangle is equal to angle P on the triangle. Your angle P on this triangle is equal to angle R on the other triangle. And angle K on this triangle is equal to angle K on the other triangle. That's what you need to do. So, if you have shown two of these, let's say show this and that, you do not need to show this. Showing that two corresponding angles are equal. If you can show that this angle is equal to this angle and this one is equal to this one, you can stop right there. Right? Because these ones are also going to be the same. If you can show that this is equal to this and this is equal to that, then you can stop right there. You don't need to show all three angles. Showing two will do the work. But if you have enough time, you can show all three of them. Another way, you must show that the ratios of the corresponding sides are equal, which means you must show that if you say SP over you see, first part SP, it's the first two letters, and divided by the first two letters there, which is your PR. It should be the same as PK over RK, which is the same as maybe SK over PK. If you can show this or this, it will do the work. You don't need just show two, you'll do the work, or show these properties, that will do the work as well. That will do the work. So what we need to do, you don't have to show both this way and that way. Just use one. Then you'll be done. And once you show this, which is this one is also true. If you can show this, that one is also true. Right? So if you can show this property, this one will hold. If you show this, that property will hold. Doesn't matter which property you use, it should be fine. So in this case, because we've been working with angles, nothing about sides, I'm going to try to use that. Look at angle S and angle P. Right? We say triangle SPK. Where is SPK? SPK, right? And triangle PRK. So look at angle S and angle P. Look at angle S and angle P. Which is your S and P? It's what you proved on the first question. It's what we were proving on the first question, which is here. Or maybe in the second question. So we have shown that angle S and angle P are equal. Right? So we can say in triangle SPK and triangle PRK. Right? We can say angle S is equal, which is this angle over here, is equal to angle P2. Because we proved this already at 10.1.2, which is on the second question, 10.1.2. Fine. Now, if we can be able to find the other two angles that are going to be equal, then we are done with this. Then look now, is SPK, which is this is our big triangle, and PRK, this is our small triangle. Look at this angle 2 here, this K2 here. Is in both of these triangles. Look, SPK, you see? Look at this angle, it's here. Look at PRK, it's also there. So they're sharing this angle K2. So you say now, my K2, angle K2 for the first triangle is the same as angle K2 of the second triangle. Because this is the common angle. They are both sharing this angle. Right? So if you manage to show that two corresponding angles are equal, two pairs of corresponding angles are equal, then you are done with this. So we can say now, therefore, triangle SPK is similar to triangle PRK, right? Now probably by angles, angle, which is the corresponding angles between these two triangles are all equal, which is even the third one, even though we didn't find it, because if I say this angle is equal to this angle, this angle is equal to this angle. So if you want the third angle of the first triangle, you say 180 minus this angle minus this angle. But it's equal to that, so it will be the same in both of them. So I'm done with 10.1.3. Now we're going to do the last question, which is 10.2, and we'll be done with this question. So let's go into 10.2. Okay, so now we're doing the last question, which is 10.2. They're saying, if it is given that SR is equal to RK, prove that ST is equal to square root 6 times RK. So, they're saying, it is further given that SR is equal to RK. So they want us to prove that ST is equal to square root 6 RK. So they're telling us that SR, where is SR? SR is this length here. It's equal to RK. Oh, sorry, SR is this length here. It's equal to RK, which is this length, SR is equal to RK. That you can see here. SR is equal to RK. Fine, so these two are equal. So we can think, okay. So they want us to show that ST, what is ST? ST is this length over here. They want us to show that ST, this length over here, is equal to, this is ST, is equal to 6 square root of RK. Where is RK? RK is this length here. You can say this is RK, this length here. This length here is also RK if you think about it, because this is equal to this. So if you go all the way from there, so it should be 2 of your RKs, because it's going to be RK plus RK. So this from SR is called RK, and this is RK, because we're given this. So this is 2 of the RKs, because RK plus RK is 2RK. Fine. So that's what we need. So we need to find ST. ST is this. So if you look in triangle STK, STK is a right angle triangle. There is your 90 degrees. So this ST is a hypotenuse. So we can say, okay, look, ST squared, which is the hypotenuse squared, is equal to TK squared plus TK squared plus SK squared. SK squared. This is your Pythagoras, right? Okay. So, 1 our ST. So we need to find SK, TK, and SK. TK. TK. Here is TK. TK is equal to PK. So we can think of this length here, PK, as TK, right? Because this length is equal to that length. So if this is TK here, so is that one. Fine. So if you look at this length of yours, your ST is this one, your RK, your TK, where is your TK? TK is this one over here, same as that one, and your SK. SK is that, which is, well, you can write SK in terms of RK because it's two RKs, right? Because look, we said to ourselves that SR is equal to RK. We said this was given information, right? Fine. Look now. Look at SK. Your SK is equal to SR plus your RK. So which is your SK? It's called SR plus RK. But RK is the same as SR, so plus another SR. Which is why I said it was 2RK. So which is what I have here. So SK is equal to 2RK, which means here you can put 2 RKs. So which means your ST squared is equal to TK squared plus plus SK squared. But you know your SK. SK is this. So which is your SK. It's TK squared plus SK squared. But our SK is 2RK. So we can say 2RK squared. So which is your ST squared is equal to your should be TK here. Yeah. TK should be TK squared plus 4RK squared. Fine. Now let's try to get rid of this so that we can write this TK in terms of SR as well. So where is TK? So this TK, can think of it, TK is this, which is that. And so what you need to do, we need to try to relate this side, right? With this side, maybe of this triangle, to the side, to the corresponding side of this triangle over here. You need to relate this TK of yours, which is your PK on the small triangle. So let's look at PK of the small triangle. So PK of the small triangle is this one here. Oh, sorry. PK, maybe of the small triangle. Let's look what it corresponds to. PK of the small triangle, there is the PK of the small triangle. It corresponds to SP. It corresponds to SP. But SP is this side. But we don't want anything to do with side. It would be better if we use this side only. So, PK of the small triangle, PK of the small triangle, PRS. PK of the small triangle correspond to SK. Okay, this is okay. I don't know what I did the first time. So, if you say your PK of the small triangle, where is your PK of the small triangle? It's this one. So, this part is SK on the big triangle, which is that. So, if I say PK of this, let me talk about triangles. In triangle, PRK and triangle SPK. We prove that these two things are similar, right? So if I take the PK here on the smaller triangle, on triangle PRK, so we say pk there. So you say your pk, and your pk, which is there is your pk, it goes with sk divided by sk. It should be the same as what? It should be the same maybe as maybe rk of the small triangle. Rk of the small triangle. What does rk of the small triangle corresponds to? Let's go. Small triangle is this one. Rk. It corresponds to pk. Right? It corresponds to pk, which is, it corresponds to this side here. Because look, pk of the small triangle, there is your p, there is your k, corresponds to sr, which is, there is your s, there is your r. Look at the position pk, and look at the position of sk. Right? Now, on the small triangle, you look for your pk on the small triangle. You look for your pk on the small triangle. You say it corresponds to sk, right? Fine. But now, let's say you wanted to look at the rk here. Look at the rk of the small triangle. Rk of the small triangle is pk of the big one. It's equal to pk of the big one. Right? So these ratios are equal. Because I explained that if two triangles are similar, the ratio of the corresponding sides are equal as well. Also, these are corresponding ratios of similar triangles. So in that case, look now, cross multiply, we have pk squared is equal to rk times sk. But look at sk, we have sk. Sk here is equal to 2 rk's. So which means what we have pk squared is equal to rk times 2rk, which is equal to 2rk squared, right? It's equal to 2rk squared. So in that case, remember now that we said that we want tk, but tk is equal to pk, right? So we said that, remember, tk is equal to pk. This was given. So look now, in that case, if you square both sides, tk squared is going to be equal to pk squared. Right? Your tk squared is going to be equal to pk squared. Which means, if you come back to this st squared, your st squared is going to be equal to tk squared, which is equal to pk squared, and they are both equal to, pk squared is equal to this thing here. It's equal to 2rk squared. So which means what you have here, instead of your, in the place of your tk squared, you have that, which is the 2rk squared plus your 4rk squared. So therefore, your st squared is equal to 6rk squared. Then take the square root, take the square root. Therefore, get that your st is equal to the square root 6 times rk. That will be the length of your st, which is what they wanted you to prove here. So we're done with question 10 of May, June 2023, and I hope it does make sense to you as it does to me. Thank you for watching. Cheers.